Hello everyone, my name is Ajay Bapu Dombade and I will be explaining the topic which is self-organizing map, which is also called as SOM. Means basically it is a fascinating topic in unsupervised learning. So we will start with introduction. So in the introduction of SOM, so self-organizing map were introduced or by discovered by uh, Teuvo Kohinen, and SOM it is an unsupervised neural network, means it learns patterns from the data without label outputs. Means as we know that in supervised learning there are labeled data points, means classification are there in the data which is easily understood by the model. So as there are no label outputs in unsupervised learning, so this SOM learns from patterns, and it is useful for dimensionality reduction. Means as there are high dimensionality images and all these things, so it divides into clusters, means also used for clustering, means grouping similar data points. And topological structures means each similar data points are separately grouped together. And to the right side, this is the image of SOM, means it basically consists of two uh, layers, which is the neurons on the downward side, which are x0, x1, and up to xn, which are the input layers. Means we provide inputs. It may be anything related to such as age, salary, income, and many more. And these are the output layers, and this the in the between, means for example, between input and output layer, the connection, means the arrows which we are seeing is the connection between, which are the weights which are like randomly taken during the input layer, and in the output there is a formation of 2D grid neurons. So now we will see how SOM works. So as we know that there is a step one which initialize neuron. So for example, as we seen in the diagram of previously of SOM, there is a input layer, and similarly this in the first stage, which is a step one, initialize of the neuron in a 2D, means we are arranging the neurons in a 2D grid array or 2D grid structure for like a pattern, to which the pattern which will be used from the input data to analyze it. So in the step 2, which will like we will provide input data points to that 2D grid uh, structure. And 2D grid structure, what we will do, one by one we will provide input data points to that 2D grid structure, and it will match that data point, which is like we have to find BMU, means best matching unit. In the step 3, as we know that in the input data point, as we see here, when we will provide one input data point, it will try to find the BMU, means best matching unit in that 2D grid. For example, which it will calculate the distance between the neurons, means finding the weight vector, means mathematically closest to that input what we have provided the input data point. So which is the closest for data point in the 2D, which will be the best matching BMU. And after in the step 4, when we will find one BMU, which best matching unit, the nearby neurons to that grid will automatically change according to the input data point, means it the other neighbors 2D points, means other neighbor will try to means try to find same related input minimum distance to which will weight vector adjusted, means the neighbors will adjust their weights according to the input point. And after that, I repeat until convergence, means until the SOM finishes training, means there is negligible change in the weights. After that, we will find that what input we have provided in the data points. Similarly, the similar data points will similar data points formation in a group which called as a clusters. And this is a working, and it will be useful for image recognitions in the company. It will also helpful for company, like for example, high dimensional data is divided into small clusters of similar data, it will be helpful. So then real world example, means it will be helpful in customer segmentation. For example, we have inputs such as age, income, spending scores. So when we will provide this input data to that SOM cluster, so it will, according to the person's age, income, spending score, it will learn through the data. It will calculate the distance according to the input, and it will form clusters according to it will be, and the output will be like a young professional family spenders. Means the data which we are providing is does not have any kind of label data. It is understanding by the patterns only, so it will be helpful in this customer segmentation in marketing. Then afterwards, advantage and limitations. So it is, as we know that it is easy to visualize high dimensional data, that whatever we have the high dimensional data, it will break down into the clusters and makes the similar data points together forming a cluster. It will be helpful for the companies. Automatically detects clusters means whenever we will provide input data to that 2D grid structures, it will automatically form clusters according to similar data points. And maintains topology, neighborhoods relationship. Means whenever we put one data point to that cluster, the neighbors also modifies their weight and tries to be close as to the input data point. And limitations means required tuning of learning rate and neighborhood side. Means when we have to adjust weight, it depends upon the learning rate. If we have high rate, it will have high change into the weight, and works best with numerical data, because alphabetical data or numerical data, it will work best with numerical data. And we will in the last, what is the conclusion, like SOM, which is unsupervised learning plus visualization. Means it will be helpful in high dimensional data. It will divide it, it will automatically find clusters and similar data points, helpful in marketing, image comprehension, and bioinformatics, and helpful understanding hidden structures in data. Thank you for watching this video.